Solving transshipment problem using Microsoft Excel. In the earlier video, we have seen how to solve transportation problem using Microsoft Excel. This is an extension of that transportation problem to transshipment problem. So here you have something in the middle. So you have the production facility in Nebraska and Colorado, and then you have a distribution center. So let's say you're growing potatoes or corn in these two states, Nebraska and Colorado, and then sending that to distribution center in Kansas City, Omaha, and Des Moines. And then they are doing some early cleaning, let's say clean the corn or potato, and then they send it to this manufacturing plant to make the potato chips. So the distribution center is in the middle. To use Excel, couple of steps we need to clean the data. So I will so this is our data. I'll copy this. I'll clean in a way so we can use the Excel solver function, which we'll show you soon. So we'll say clean data. We'll clean this in a way so Excel we can use that solver in Excel. So first thing, we need to understand whether we have more production or less production. So if you have more production, we won't be able to ship all of them. So we want to see how much we are producing. We're producing 750, and let's see how much is the demand in those chips making plants. So some of the demand from these different places that make potato chips are, so here you have more demand, so we won't be able to fulfill it. So all right, so that's one step. Second, we're going to move this cost here. I'm just going to do some operation here so that we can use Excel more effectively to solve this problem. Just stay with me. So we have this cost here moved. Now Excel will start with 0, and then it will find the optimum number of items shipped from say Nebraska to Kansas City and so on. So it will start with 0, so we need that, and then we need to sum the amount that is going to Kansas City from Nebraska and Colorado. So we're going to name that as shipped. So the amount we're going to ship from this two state to this distribution center. Also, you're going to type a shipped column here. And this is the amount shipped from Nebraska to these three different cities. All right, so here you go. Oh, no. Okay. Similarly, here we need to calculate the total ship from Kansas City to these three plants, Chicago, St. Louis, and Cincinnati. And then just copy all the way down. Again, we need a column row here named shipped, equal to sum of these three. And then go copy like this. We also need a transshipment constraint. I'll show you what that is. Transshipment constraint. So we need that for these three distribution center. If there is not much demand, we just don't send this stuff to the distribution center and wait there. It just wastes us of money to do that. So basically, whatever goes to Kansas City must get out of Kansas City. So this is get out of Kansas City. And then whatever goes to Omaha, it has to get out of there. It doesn't stay there. And then whatever goes to Des Moines from this two state, then it get out of Des Moines. So, and then we need a cost objective function, which is basically sum of, we haven't find the cost here. So these are the zeros right now. However, Excel, when you run the solution, the Excel will replace this 0 with some number. So the optimum number of item that's going to be shipped from Nebraska to Kansas City to minimize the cost. And we know that $16 is the cost to ship from Nebraska to Kansas City. So we can develop a cost table here, simply whatever ship times this dollar cost to ship that item. Let me give some little bit that, and then basically copy that. I will also copy that here too. Sometimes I would like to check if I have selected the right after copying. Looks good. So the cost function will simply do sum of all of these cost, shipping cost. Now we are ready to run the Excel solver. However, we want to keep this clean data. Once we run this solver, it will replace all this 0 with optimum number of size that will produce the cheapest amount of cost. So we'll copy this data, clean data to a new sheet. I'll name that as solution. And then we'll run the solver here. So you have to click on the data tab, and then you go find the solver here. Now if you don't see the solver, you can right click it, customize ribbon, add-ins, Excel add-ins, and then just check that box says solver add-in. Will bring that solver right here. You can also go to file, option, and then same window will pop up, Excel add-in, and then you can do that way too. So click on the solver, and then we want to optimize our cost function, which is cell B18, and then we want Excel to change now 2 tables. In the transportation problem, we only change numbers in 1 table. This time Excel will change numbers in 2 tables. So comma this second table here. So it will produce number for both of these tables. Now it will use a simplex linear programming algorithm, and then we're gonna add some constraint here. So first constraint is for the production. So we have less production, so we'll be able to ship all of them. So we're gonna use an equal sign constant here like this, then add another constraint. However, we won't be able to fulfill all the demands, so that will be basically less than the total demand we have. We also need to add another constraint. All these transshipment points should be 0. We don't want to send anything there extra. Whatever these 3 chips making plant in Chicago, St. Louis needs, we only send that much to the distribution center, so that we don't stockpile in the distribution center, because that's going to be an extra cost, and if there is no demand, it's sitting there occupying space, not really efficient. So I think that's all the constants we need. Now if we hit OK, we should be able to see a solution. So this is the solution for that problem. Now to double check how we did, let's calculate the amount of sheep we can. So we can basically see some of this. As you can see, this is 750, so we really don't need that. Also demand shipped. For demand, let's see if we have shipped 750 or not. We did 750, so looks like the solution worked out fine. So the cheapest cost would be 14,950 to do all of this. You can also look at this total cost. If sometimes if a question asks in the exam that what is the cost for shipping from this Nebraska, Colorado to this distribution center, that would be $10,000. You can also add the cost of shipping from the distribution center to the potato making, chips making plants in Chicago, St. Louis, Cincinnati, and that would be 4,950. So that explains the transportation model.